Okay, cross-linking, my favorite when it comes to polymers. So the book kind of introduces cross-linking and basically says, hey, if you have two long polymers, cross-linking is when you add something to like a batch of polymer substances that interacts with the substances and kind of links everything together. So it takes like one string and another string and like hooks them together and holds them. And so your book starts out with giving you this image, which again, I kind of color coded. So the yellow again are, some of those main chains. And then the blue would represent a cross-link. That's a substance that has come in and really just like grabbed a hold of one and grabbed a hold of another and is holding those two polymers together. And so that is what cross-linking is. Very different from branched, okay? Branched is just a polymer with its own branches, whereas cross-linking is multiple polymers with these clips like holding them all together. And so I'm going to try to show you my desk here of what, maybe I can lift my laptop up. We're just going like completely unedited here, guys. Authentic to the max. Okay, so here's my polymers, right? So they're all kind of slipping past each other, and I can, grab one all by itself. They can kind of slide through like this, all right? So this obviously has no cross-linking, but if I take some clothespins, right, and clothespins may represent like borax and slime. So when you have glue, this is glue. It's very slippery, okay, before it dries out, obviously. But then you add the borax, and the borax kind of makes that slime, and it like links everything together. So if I just, randomly mix some borax in, I hope this works, and add some cross-linking to my polymers. Wow, I don't know how well this is going to work, but we are going to roll with it because that is what remote learning is all about, you guys, is just kind of doing this. So now I have some pretty sweet cross-linking happening here, and guess what? When I pick it up, they're supposed to all be like clipped together. I don't know how well this is gonna, oh well, we're just gonna roll with it. Let's do that, maybe. Yeah, so see how they're all like stuck together now? They don't all, I can't just like pick one out. The rest kind of comes with it because they're all stuck, okay? So these paper clips are representing the cross-linking that happens. And in our slime ingredients, the glue is the necklaces. That's the normal polymers. They're all like slippy past each other. But when you mix in that borax, it connects everything and holds them all together. And it really is kind of messy like that. But that's what happens at more of the chemistry level. So there you have it. My daughter's necklaces and my clothespins for all the chips that I'm eating right now as I sit at my home all day to keep them closed. Obviously, I'm not using the clips because the chips don't last very long, but I don't want to talk about that. So the rest of the questions here on cross-linking just is like, hey, draw some examples using our squiggly lines of what this cross-linking could look like. And so here's a picture of, my original lines here, and then those zigzags are my representation of cross-linking. So it holds them together and they can't slip past each other because, well, they're stuck, they're linked up. And here is another cross-linking. Number 6 says, okay, well, what about branched polymers? Well, here's branched polymers, but same thing. The cross-linking, you just have more cross-linking because there's more branches for these links to like come in and grab a hold of. And so that's really, there's no difference. It just means more branches or more cross-linking if you have a branched polymer. Okay, but if you have a non-branched polymer, like a linear one and cross-linking, same idea, just not as intense because there's not as many things for it to hook onto. That was a lot. You may need to kind of rewatch that last little segment, but we're going to wrap up this with one more video. Holy cow.